Hey guys, and welcome to 2.4. This lesson is all about clearing fractions. I'm going to kind of go through the clearing the fractions process with you, pretty detailed. Because once you learn how to clear fractions and get the fractions out of the way, then you just jump into what looks like what we did in the last lesson, and you can sort of move forward on that pretty easily. But Becca is pretty serious about learning this process of clearing fractions. It might make things a little bit more complicated right now, but once you learn how to do it, it's actually a very useful tool. So, with that being said, I want you to make sure that you really read 59 pages 59 through 61. I'm going to go over the practice problems 2.4 with you pretty specifically, and then I'm not going to do any of the review problems. I think that you should be good to go on the review problems, but I'm going to cover the practice problems pretty detailed so that I know that you know how to clear fractions. I'm going to start with number one, and number one says z plus 2/3 equals 6 and 1/6. Okay. In order to clear the fraction, the very first thing I need to do is find a common denominator. Okay, if I'm clearing the fraction, if I look at a problem like, oh man, there's a lot of fractions in this problem. I think I want to clear the fractions. Then the first thing I need to do is find a common denominator. And what I need to realize is that z is just z over 1 because anything including an unknown is just over 1 as a fraction. So when I look at the denominators that I currently have, I have a 1, a 3, and a 6. And I need to determine what is the common denominator. What is one of these digits that all of these digits can divide into? Well, it's 6 because 6 can divide by 6 one time. 3 can divide by 6 two times, and then 1 can divide into 6 times. So the lowest common denominator is 6. So 6 is the number that I'm going to use to clear my fraction. Let me show you what that looks like, okay? If I rewrite my problem and I have z plus 2/3, and then, oh, that's a third, equals 6 and 1/6. And I want to clear my fraction. Then what I do is I multiply this entire thing by this LCD of 6. Okay, I multiply the entire thing by my LCD. And what you do to one side, you have to do to the other. So I'm literally just multiplying both sides separately by the LCD, my lowest common denominator. Now, because I've done this, I now have a situation where I have parentheses, okay? As I need to really think about my please excuse my dear Aunt Sally, my PEMDAS, and need to think about what I should do and in what order. Okay, so I need to get rid of my parentheses here, and I can't because I don't have like terms here. So I'm going to have to use the distributive property, and this is what you do when you clear the fractions is you find the lowest common denominator, and then you use the distributive property. So this isn't a surprise. 6 times z is just going to be 6z. Now, 6 times 2/3. I'm going to come way over here and show you this. If I have 6 over 1 multiplied by 2 over 3, I can reduce if I want to, okay? I could say I'm going to reduce this 3 and this 6, and that's going to reduce to 1 and 2, which is going to give me a 4. Okay, I could also say 6 over 1 times 2 over 3. I could just multiply straight across, and I could say this is 12 over 3 because I multiply straight across some of the denominators. And we can say that this says 12 divided by 3, and 12 divided by 3 equals 4. It doesn't really matter which way you want to do this process. As long as you understand that this positive 6 multiplied by this positive 2/3 is going to give me a positive 4, then you're in good business. Now, over here, I'm multiplying 6, and I'm timesing it by 6 and 1/6, and that just makes for a really complicated mess. So the best way to start off with this one is to turn this mixed number right here into an improper fraction. So I'm going to say 6 times 6 is 36 plus 1. This is actually 37 over 6 multiplied excuse me, by 6. But we know 6 is 6 over 1. Okay, now right here, I can either reduce my 6's and cancel them both out to 1, or if I didn't notice that and I just multiplied straight across, 37 times 6, I cheated and went ahead and did the math ahead of time, it's 222. And if I multiply this straight across, I'm going to have 6. And 222 divided by 6 actually is 37. The other way I could have done this is to recognize that these can be reduced to 1. So then 37 times 1 is just 37 over 1, which is 37. Okay, so now my problem looks something like this. 6z, 6 times z, plus 4 equals 37. Now from this point on, you should probably know how to do this. I need to subtract 4 from both sides because I want to get that 6z by itself. 6z, 37 minus 4 is just 33. Now I need to divide by 6 to get rid of this 6 that's multiplied by the z, and this is going to reduce down. And my final answer here is going to be z equals 33/6. Now, this is an improper fraction, and Abeka really, really loves for you to reduce improper fractions and actually just really reduce everything. They're cool with you leaving it as an improper fraction, and I am too. You can switch it to a mixed number if you want to. Just whatever you do, you need to reduce. And I'm looking at both of them and saying they both can be reduced by a division of 3. So 33 divided by 3 is 11, and 6 divided by 3 is 2. So my final answer is z equals 11 over 2, which does say 11 divided by 2. So if you wanted to turn that into a mixed number, you can, but you don't have to take that extra step. This is sufficient. If you want to leave it as a mixed number, that's completely cool and saves you a little bit of time. It does ask you to check the problem though. So our final answer is z equals 11 over 2. I'm going to jump up here and erase a whole bunch of stuff so I can try to create some room. This eraser tool is kind of crazy. It sometimes wants to erase and sometimes it really doesn't want to erase. Okay, I think I have enough stuff out of the way now that I can jump back in and do my actual problem. So my original problem was z plus 2/3 equals 6 and 1/6. So I'm going to substitute this in for z. So I have 11 over 2 plus 2/3 equals 6 and 1/6. I'm going to have to get a common denominator, okay, because I'm adding fractions. My common denominator is going to need to be 6 because the common denominator for 2 and 3 is 6. So just so I show you, 2 times what number gets me to 6? It's 3. So whatever I do to the bottom, I have to do to the top. So this is going to be 33/6, which we already knew that because we'd reduced it down. 3 times what number gets me to 6? That's 2. So then 2 times 2 is 4. So if I get a bunch of junk out of the way and finish out writing my problem, equals, and if you remember before, I said that 6 times 6 was 36 plus 1 was 37. And I said that this was the same thing as 37 over 6. Then now I can just add up my improper, I can add up my fractions to equal this improper fraction. And 33 plus 4 is 37/6. Because we only add numerators, remember, and 37/6. And this is how I check my final answer. Okay, so that's what number 1 looks like. I use the concepts of clearing the fractions, found that lowest common denominator, and then use the distributive property for both sides. And then I just cleared down and solved my problem like I normally would. And then I had to check. So that was quite a big amount of work to do for number 1. So I promise not to be too crazy and too needy. Let me go ahead and work number 3 for you. Okay, number 3 is x plus 3/4 equals 7. Okay, now we know that 7 is actually 7 over 1. So when I'm looking to clear the fractions, I can clear the fraction with a 4 because 7 over 1 is 1, and then the common denominator and x over 1 is 1. Like if I wanted to say there's a little denominator here and there's a little denominator here, I can do that. But we know the LCD is going to be 4. So if there's only one denominator, it makes it quite easy in determining what the LCD might be because it's literally just going to be whatever the one denominator is, and so this one's a 4. Okay, so I'm going to multiply both sides by 4. And I'm going to have to use the distributive property, and that's cool. We already knew that was coming. So this is going to be a 4x. Now I have 4 times 3/4. Okay, just kind of jot this over here. I have 4 over 1 times 3 over 4. Well, my 2 4s can just, boom, they can just cancel out. 1 times 3 is just 3, and 1 times 1 is 1, so that just means the whole business here ends up being a positive 3. Hopefully you're not having a problem with that. Put my equal sign down, and then 7 times 4 is just 28, so that's pretty easy. Okay, now this should look a whole lot like what you've been solving. We know that I've got to get rid of this plus 3, so I'm going to have to subtract 3 from both sides. This leaves me with a 4x equals 25. Now it says 4 times x equals 25. The opposite of times x is divided. So the opposite of times 4 is divided by 4. These are going to cancel. This is going to leave me with an x equals 25 over 4. Now listen, I am not a big fan of leaving all these as improper fractions, but Abeka is. And I will say that the reason that they do that is because they're asking you to check it. Okay, if they weren't asking you to check it, they probably wouldn't want you to leave it as an improper fraction. But this is actually the answer that they're looking for. Now let me show you the recheck. Okay, I have room to do it here. X plus 3/4 equals 7. And this is going to become pretty handy because when I put in 25 over 4 and for x, 25 over 4 plus 3 over 4. I can just straight add it because I already have a common denominator. 25 plus 3 is 28 over 4 equals 7. And remember, 28 over 4 is the same thing as 28 divided by 4, which is 7. So it's 7 equals 7. So we're looking for this, and we're looking for this. And then we'll know that we have our complete answer. Okay, this is clearing the fractions using the lowest common denominator. So you should be pretty good at using this. I'll go ahead and do, I'm going to only make you do the odd. So I've done 1 and 3, and I'm going to do 5. And then after that, I'm going to send you smooth sailing. So 1, 3, let's do 5 together. And then this baby will be yours. So here's 5. I have 1 and 3/14 equals k plus 5/7. You know I can't stand it. I have to move it. I have to say k plus 5/7 equals 1 and 3/14. I just have to. It irks my nerves if I don't do it the other way. We know this k is actually a k over 1. If we want to put it that way. So you can look at this and you could be like, oh, the lowest common denominator between 7 and 14 is going to be 14. Because 14 can be divided by 14 and 7 can be divided by 14. So they're both divisible and that works. So now I need to do a little bit of work. I'm going to get rid of this over 1 because that's just redundant. We don't need that. So I'm going to multiply both sides by that LCD, which is 14. And I just put parentheses around it because that's the easiest way to show multiplication. Remember, what you do to one side, you have to do to the other. And I know I'm going to have to distribute. It's part of this process. It's what we hope to be able to do. So this is going to be a 14k plus, now let's take this math off to the side, 14 over 1 times 5 over 7. And these are going to reduce to 1 over 2. And 2 times 5 is 10. So this whole business is going to be plus 10. Oops, that's kind of close, but you can read it. And then over here, I have 1 times 3/14 times 14, and it's easier to turn this into an improper fraction. So 14 times 1 is 14, plus 3 is 15, 16, 17. So it's like saying 17 over 14 times 14 over 1. And these two dudes are going to reduce down to 1 each. And that's going to leave me with 17 over here. Okay, so we're smooth sailing up until this point. Now, at this point, we want to get rid of this plus 10, so that's a minus 10 to both sides. That's going to leave me with 14k equals 7. Okay, 14k equals 7. Now it says 14k. 14k is the same as 14 times k. We know that the inverse of times is divided by, so I want to say 14k divided by 14. That's going to leave me with k equals 7 over 14. Now I should know to reduce this. 7 over 14 is the same as 1/2. Okay, so this is what I'm going to end up with here. Now, when I put it back in to check, it might be easier to leave it 7 over 14, okay? And I'm going to put it into this side because I like it written that way. So I'm going to say k plus 5. Ooh, that's not 5, that's a 7. K plus 5/7 equals 1 3/14. So I'm going to drop in 7 over 14 for k because it's going to be easier. Plus 5/7 equals 1 3/14. And I actually could get real frisky right here and say it's 17 over 14 if I want to, and I might do that in the next step just to make it easier for myself. I'm adding fractions, so I have to have a common denominator. My common denominator is going to be 14, so that means I can just leave this first fraction intact. So I'm going to make this a 14. So 7 times what gets me to 14? It's 2. So that means 5 times 2 is 10. I don't know where this random mark came from. And then remember I told you I was going to go ahead and make this my 17 over 14, which is what we found out it was earlier. And if you want to know how I did that, I just turned this into an improper fraction. 14 times 1 is 14, plus 3 is 7. If you need me to draw a picture of this or you don't understand it, please tell me. 7 plus 10 is 17/14 over 17/14. And this indeed is true. So I'm looking for this, and I'm looking for this. Now, I just did 1, 3, and 5, and you're only going to have to do the odd numbers, so you should be pretty good to go here. Don't get tripped up on the ones that are more challenging. Just remember, we're finding the lowest common denominator, multiplying each side by the lowest common denominator, and using the distributive property to clean out your parentheses. And then you're just going to move forward with the order of operation, undoing as you go to eventually have your unknown all by itself. This is the point in algebra that if you are not with me, you got to speak up. Shoot me an email. Tell me something. If you're struggling by the end of this week, I need to know so that we can evaluate and kind of fill in any holes that you might have. You are good to go. Finish out 2.4. Do the problems I assigned for the review of 2.4. Pay special attention to the problems that I'm requiring of you this week because that'll be pretty nice. And have a great week. Bye.